Okay, hi and welcome to the example video for solving with square roots. Again, we are solving quadratic functions, which we'll learn a lot more about in the next week or so. But before we do that, we can at least solve them at this point. So if we're given an example like this, x squared equals 12, we're going to use square roots to solve that type of function. So what are we going to do? We're going to take the square root of both sides. Why? Because we want x, not x squared. What does that do? Well, these square root and that square cancel, leaving an x on the left, and on the right, we're left with, and don't forget, you have to add plus or minus because there's two versions of this possible answer. So we're left with the square root of 12. 12 is going to break up into 4 times 3, and we know 4 is going to be 2 squared. So square root of 4 is 2. We're going to be left with x equals plus or minus 2, because it's multiplied, times the square root of 3. Again, we could write that out. X equals 2 square roots of 3, and x equals negative 2 square roots of 3. That's what that would indicate. All right, let's try that again, this time with a negative value. Again, taking the square root of both sides to get to this x here, those are going to reduce away. X is going to be equal to plus or minus, don't forget, the square root of negative 36. How do we deal with that negative? Well, we know that negatives are imaginary numbers and they come out front as an I. So it'll be I square root of 36, and we know the square root of 36 happens to be 6. So this will be plus or minus 6I and no square root because the 6 comes out. Okay? All right. Let's move down and try that with an additional constant on there. So if this constant happens to be there and we're trying to get to that n and solve for it, we're going to go ahead and subtract 12 from both sides, and we're going to be left with 3n squared equals 0. Don't let that freak you out. We know that we're starting to become more comfortable with the fact that 0 just means that we're solving. Doesn't mean anything bad, doesn't mean that there's not anything there. There's a 0 there, and we're going to treat it like a 0. So to finish off, we're going to go ahead and remove this 3 so we can get to that n squared. So we divide by 3 on both sides, and n squared equals 0. Of course, 0 divided by anything is always 0. Square root both sides, and this one looks super easy. We will write n equals plus or minus, and the square root of 0 is 0, but really, is there a positive and negative version of 0? There's not. So n equals 0. That looks like where all of the other ones we've done, we have two solutions. This one would be a single solution if you're paying attention to what's going on here. And that's perfectly fine. We'll talk about more of that when we get to quadratics. All right, let's do another one that looks similar to that. I'll go ahead and add 9 to both sides. We're left with x squared equals, we get negative 7. So x squared equals negative 7. Again, to get rid of this square, we're going to go ahead and square root both sides. And we're left with x equals plus or minus the square root of negative 7. Now we got to deal with the negative here. Remember, the negative is going to become I. That's an imaginary number. So we're going to have plus or minus I square roots of 7. And that's where we leave that one. It's such an odd answer and we don't know what to do with it at this point. That's fine. We'll talk more about that later. But that is the result. It does represent what would be its solution or its x-intercepts if it had some. But we're going to leave that there. All right, let's do 2 more quick examples, this time involving an expression that's squared, and we have to get to that x. Again, we would not want to multiply this out. We're going to go ahead and take the square root. Oops, not yet, because this 9 says I need to be moved first. So we're going to move that 9. Left with 2x minus 1 squared equals 9. Now we can square root both sides. The square roots and the square cancel. 2x minus 1 equals plus or minus, and we can go ahead and change that square root of 9 to 3 because we already know what it's going to be. Let's move this 1 over now by adding 1 to both sides, so we're going to be left with 2x equals 1 plus or minus 3. Remember, it has to go in front. It doesn't go with the 3 because the 3 is 2 versions of answers. We're kind of carrying 2 answers there with us, and now we're going to divide by 2. So that whole thing will be divided by 2, leaving us with x equals 1 plus or minus 3 all over 2. Now, we wouldn't leave that one there because this is something we can clean up. So we're going to separate it. So x is going to be equal to 1 plus 3 over 2. We're taking the positive version. And x is going to be equal to 1 minus 3 over 2. And let's clean those up. That's not too hard. 1 plus 3 is 4. 4 divided by 2 is 2. So one possible solution is x equals 2. And the other one would be 1 minus 3, which would be negative 2. Negative 2 divided by 2 is negative 1. Again, we could even change these into intercepts. We know there's an intercept at 2 and 0, and we know there's an intercept at negative 1 and 0. All right, let's do one more quick example. This one we've got here has a multiplier out in the front, has a 2 that has to be added, so let's clean those up so we can get to that square rooting that we need to do. So subtract 2 from both sides, left with 4 times x minus 1 squared equals 36. We're going to go ahead and divide now by 4 to both sides, leaving us with x minus 1 squared equals 9. Now we're going to square roots. We're going to be left with x minus 1 equals plus or minus 3, because we took the square root of 9. And now we're going to add 1 to both sides, and we're going to be left with x equals 1 plus or minus 3. Let's clean that up, though, because we can. X equals 1 plus 3, and x equals 1 minus 3, which is 4 and 2. Again, we can even write these as intercepts. Choose we do. All right, so there's a couple quick examples for you. You've seen all the various forms of how to solve by square roots for a quadratic that we're going to be moving into. Thanks for watching. We'll see you in class for some problems.